True or false? A molecule and its mirror image are always the same. Lock your answer. The answer is false. Sometimes the mirror image is a different molecule. Those pairs are called enantiomers. In this video, you'll learn what enantiomers are, how to spot them, how they behave, and why they matter, from naming rules to real-world examples. Enantiomers are a type of stereoisomer, two molecules that are mirror images, but not superimposable. They usually arise when a carbon is attached to 4 different groups. That carbon is a chiral center. Rotate one all you want. If it can't perfectly overlap its mirror, the pair are enantiomers. Same formula, same connectivity, different 3D arrangement. With one chiral center, it exists as 2 enantiomers, R2-bromobutane and S2-bromobutane. Inverting the configuration at every chiral center in a molecule gives its enantiomer. Here, that's R to S. However, not every mirror pair is different. If a molecule is achiral, for example, it has an internal mirror plane, like some meso compounds. Its mirror image is the same molecule. So far, we've covered identify a chiral center, check non-superimposability, and remember, flip all chiral centers to get the enantiomer. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. In nature, enantiomers can behave differently in chiral environments. One lactic acid enantiomer is what your muscles make during intense exercise, while the other is produced by bacteria in the gut. With carvone, one enantiomer smells like caraway, its mirror like spearmint. Same atoms, different nose. Most physical properties of enantiomers are identical in melting point, boiling point, and density. But they rotate plane-polarized light in equal and opposite directions and can react differently with other chiral things like enzymes or receptors. A common mistake: when a molecule has multiple chiral centers, inverting just one doesn't give an enantiomer. It gives a diastereomer. Only when all centers are inverted do you get the true mirror image. And if the mirror image of the diastereomer turns out to be the same molecule, hello meso. So how do you assign configuration? Number the 4 groups by atomic number. Point the lowest priority away, then trace 1 to 2 to 3. If the path goes clockwise, it's R. Counterclockwise, it's S. Flip the mirror, and R becomes S. Why does it matter? Because many biological targets are chiral. Often, only one enantiomer fits the receptor best. That's why chemists and pharmacologists care so much about stereochemistry in drug design and biosynthesis. Quick recap: a carbon with 4 different groups. That's a chiral center. Flip all the centers and you get its enantiomer. Same formula, but a mirror image 3D shape. The difference? Revealed by polarized light and crucial inside chiral biology. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.